Welcome back to another lesson in MTH1W. Today we'll be looking at density, limits, and infinity. When we look at the definition for density, we can define it as the space between numbers in a set. And here we see that if there's less space between, that will mean that there is going to be a greater density. And so if we look at an example, let's say we have this first set, which is 0.1, 0.2, 0.3. Remember, 0.1, 0.2, and 0.3 would be what we call elements in the set. And we can say that this is more dense than if we had the set 1, 2, and 3. And so here, if we look at our definition, the less space there is, the greater the density. So here we see that between 0.1 and 0.2, there's a difference between 0.1 versus the set 1 and 2 and 3, between 1 and 2, there's a difference of 1. So again, the less space there is, the greater the density. Another example is if we look at the set of real numbers. The set of real numbers is more dense than the set of integers. So if we think about real numbers are all the numbers that encompass values in a number line. And so, for example, if we looked at something between 1 and 2, the integers would have a difference of 1, but the real numbers would have very, very small differences between. So again, less space in between, greater density. When we look at the definition of infinity, it's something that is larger than any number. So something that is larger than any number. Or smaller if it's to negative infinity. And we represent infinity using this symbol here. And so it's important to note that when we talk about infinity, it's a concept rather than a value. Okay, so it's a concept, not a value. And we can't define infinity, but we can understand it as a concept. So here, if we have a set from like 1 to 2, and assuming that these values are an element of real numbers, we can say that there are infinite numbers of values in this set. And here next, if we have a set, so 1, 2, 3, 4, so on and so forth, we see that if it continues, it will continue to infinity, which means that we can say that this has a limit to infinity. Finally, when we look at limit, the limit we can define as the value that a pattern or a graph will approach but will never touch. And so here, if we look at an example, we have 2.1, 2.01, 2.001, and so on and so forth. So the pattern here, it sees that if we continue this, it would get closer and closer to 2, but it would never actually touch 2. So here we could say it has a limit of 2. If we look at an example of a graph, so we draw a graph here, you see that this particular function will get closer and closer to 0, but will never actually touch 0. So here we can say has a limit of 0.